Okay, I can see the recording started, so I will kick off. Thanks very much for joining us on a Saturday afternoon, everyone. It's really great to be here with you. My name's Fergus. I'll introduce myself a little bit on the next slide. But just to introduce the session, I'm going to be talking a bit about bringing AI to life. So using different Microsoft Azure cognitive services and little pieces of AI together to really come to like a functional robot with lots of intelligence and loads of cool features, and talk a little bit about how we can work on those, how we can actually expand those, and customize things and learn a little bit more about AI in the process. So my name is Fergus. I'm based in London. I work for a company called Avanade. Avanade is essentially a consulting firm. We are a Microsoft and Accenture joint venture. So we work very closely with our partners at Microsoft in delivering Microsoft technology. Specifically, I sit in our emerging technology team at Avanade. This is a really cool team that kind of explores new technology from Microsoft, gets to play around with some of the tech that I'm going to talk about today. And kind of test it out for our clients. So whether that be quantum computing that you can see here on the left, robotics that we're going to talk a little bit more in detail about today, as well as AI, VR, 5G, next generation networking, lots of different topics. So I'm really happy to be able to talk to you today specifically about AI and like how easy it is to get started in the world of AI and how easy it is to deploy some of these solutions. So the first thing I want to do is, I can't quite see what's on the camera, but hopefully you can see behind me, I've got my little friend Rory here. So Rory is a Stretch RE1 robot. So it's a robot that has been, and I'll just start this video off as I'm talking. Stretch is a fairly off-the-shelf, easy to use robot. It's made of off-the-shelf components. For example, the camera system is actually just an Intel camera that you can buy off the shelf. It has the lift and the motors that you can see here, so it has the ability to move around independently. It's also got that lift with an arm on it, so the arm can stretch out and in. It can look around with its head. It can also lift that arm up and down. And it's got a gripper at the moment on the end, which allows it to grasp objects. There's also some different tool heads that you can put on should you be interested. For example, it comes with a whiteboard pen, so it can actually draw things out on the whiteboard. So out of the box, Stretch comes with lots of well understood components. It comes with lots of open source drivers, so it's really easy to interact with and develop for, because all of the components it uses are open source. It generates lots of data, so it's got a great camera system on it here. It also, you can just see, if I play this video again, you can just kind of see at the bottom, it's got this spinning black disc on the base of the robot. That's actually a LiDAR unit that's actually able to map the surroundings. It also has sensors in its limbs, so if it hits anything, it's able to understand that it's hit a limit or it's collided with an object. And it also comes with like lots of pre-orchestrated demos. The demos that it comes with, interestingly, are all about running AI on board the robot. So trying to make sure that you're using AI models such as object detection or facial recognition that are small enough to fit on the fairly limited compute capacity that's left over on the platform. So obviously we're using quite a lot of compute capacity to do all the things, running all of the systems, running the camera, using the lifts. So we need to have models that are quite small. What we're looking at today is actually using the cloud. So using good internet connections to the cloud to actually offload some of the processing power in order to get more value from the AI that we're doing and the scalable AI. It is also possible to take some of the services that we're going to talk about and put them directly onto the robot in order to speed things up. But if you have a good internet connection, you can also do them pretty quickly with the cloud compute. So this isn't technically about the topic. I just wanted to talk to you a little bit about some other applications that we've been working on before we move on. So this is actually a NextMind controller. Oops. So I've got one here as well. So it's just a small set of sensors that sit on the back of your head. And we've been working closely with the developers of NextMind to actually generate a new control system. So I'm actually in this video able to control the robots entirely using only my brain. The way this device works is it essentially reads the electrical impulses going through your head or your brain and uses that to make decisions about what you're looking at on the interface. So with the control interface, I'm actually able to move the robot, pick up this tennis ball, completely only using sort of my concentration and my brain power, which is amazing. If you ever get the chance to try one of these, I would definitely recommend it. They're in development right now, but hopefully they'll be. You'll see this sort of device more and more in the future. Not necessarily to control robots; they're also used for sort of assistive gaming. But in this case, we're looking at robots as kind of assistive technology. So maybe to help someone who isn't really able to manipulate the fine controls. So traditionally, we might use something like an Xbox controller with some small joysticks and small buttons. Not everyone's actually able to use those that well, especially people who may need assistance from robots in the first place. Today, we're going to be talking more about how to automate the robot and how to use the sensors on board the robot to actually build a more intelligent platform. So what I've done is I've kind of drawn out the things that I want to talk to you specifically today, and kind of explain what we've done in building a chatbot around the robot. So you may be familiar with the concept of chatbots especially they usually tend to be text-based. So, customers or users of a chatbot can type a message, send that off, and something will happen. They'll either get an answer to their question or a response will actually be actioned at some point. So that might be if you were an internet provider, you might have some questions about your bill. You might have some technical questions about your connection that it would traditionally take a lot of time or effort for somebody to be in a call center, to answer the phone, to find out all of the required information, and to actually give an answer back. So people are very interested in chatbot technology, which can help reduce the number of calls that actually get through to a call center by taking the easy ones away. So, for example, some call centers were reporting that sort of 40 or 50% of the calls they were getting were because people forgot their password. So, well, let's make a chatbot that can actually help you out with that, tell you what button to click, tell you what processes to go through, and then we can actually reduce the volume of calls by 40 or 50%. But chatbots do have other, that's a huge use case that's really helpful out in the enterprise, but we have other uses for them. You may have used devices like Siri, like Alexa, chatbot assistants, which use very similar technologies behind the scenes to help you complete everyday tasks or make things easier with a voice interface. And that's what we're going to be looking at here today, is actually using Microsoft's voice-based cognitive services to enable the robot to hear and also to speak. So on a very high level, what we're actually able to do on the robot is say something to it or give it an intent. What we do is we then send that off to Lewis, and I'll explain what Lewis is in a little bit more detail if you're not familiar with that. And then depending on the outcome of what we get out from Lewis, we can send the commands or the messages either onto specific actions. So here I've put find, see, move. So that might be the example we're going to go through is like find a tennis ball, see, kind of understand what can you see, what can the robot see, or actually move. So I can actually say to the robot, hey, move your arm up, and it will move up. And I can try and give you a demonstration of that near the end. It can't listen to me talking to you and the robot at the same time. So we'll try and do that a little bit later. Q&A Maker, I'm also going to show you in more detail. You might be familiar with that. it's essentially a knowledge-based repository, which allows us to really, really quickly build up question and answer pairings for lots of different questions that you might have for the robot, that you might have about an organization, that you might have about a technical question that you want to answer. We then get 2 responses from that, which is if we go again to the not understood. I think I've got those flipped around the wrong way. Not understood goes to I don't understand, whereas understood would actually produce the answer. And I'll give you an example of how we actually do that on the robotic platform in just a second. And then, so I'm going to jump out now to just some examples of how you can do that in the browser, in the portal, and then we'll come back to the presentation to have a look at some of the vision intents as well. So I wanted to start off with LUIS. It stands for Language Understanding and Intent Service. I think the S is for, I can't remember. So what LUIS is it takes in statements or questions in text and it assigns it to a specific intent, or what we call an intent to do something, and then it will return which intent that that LUIS thinks the question or the statement was related to. And then it's up to us to do something with that information. Okay, so you can imagine with Alexa or Siri, we might say, hey, what time is it? That would fall into an intent called time. We actually have one on the robot as well. And it would be like something like, what's the time now? What is the current time? What time is it? Lots of different ways that people can ask this one question. What LUIS allows us to do is attribute all of those different ways of saying something to one intent, so that when another user or we ask a similar question again, we get one intent back. But then it's up to us with those intents what we do. So in the time intent, what we would want to do with Siri or Alexa or on the robot is just to speak out what the current time is. If this was a text-based chatbot, we'd want it to send a message to the user saying what the time was with a sort of text-based message. So depending on our application, we're going to want to do different things or look at different results. So we've built quite a few different intents for the robot. So there's a intent around calibration, because the robot actually needs to calibrate itself, around moving. There's one around a joke, so it can tell you a joke, which is another thing that Siri and Alexa can do, for example. It can also has a vision intent, which we'll talk a little bit more about, which is like what can the robot actually see, and it can also query the weather. But the weather is actually an interesting one. LUIS comes with a whole load of pre-built intents. So there's some around the calendars, there's some around communication, emailing, for example. This can be really helpful if you are building your own chat bot or text-based service or anything where you have user queries come in which are natural language. You can do a whole load of things around automation, home automation, getting addresses, doing lots of different functions. A lot of these aren't that relatable to the current project, because we wouldn't necessarily want the robot to be able to send an email. Maybe that's something we'd want to do at some point. We can add later. The most obvious one to use was like a weather. So in these pre-built intents, you can see that Microsoft have actually already gone in and put loads and loads of different ways that people ask the weather. We also have these things called entities. So what's the weather like in London, where London is a key entity that we need to understand that the user's input in order to actually report back what the weather is like for the specific user. We also need to understand things like in, so where we're talking about numbers for times, numbers for inches of snow in this case. Lots of different things that we can pull out of that, and we pull those out as entities. You can also add your own entities. So for example, we've had to add open and close as entities for the grip, up and down for the arm, or in and out for the arm as well. But again, lots of different pre-built entities, like numbers, like directions, really useful. Really useful. So if we give that a little test, for example, we could say, what is the time, please? And you can see what we get back is that we get the intent. Sorry if this is a bit small, I'll try and make it bigger. There we go. What we get back from asking what is the time, please, is the intent time and a probability. So if we said something like that it isn't trained to understand, you can actually see that we do get an intent back. So we get a weather query, but it's with a very low probability. And these probabilities we can then use to make decisions about what to actually do with that. So for example, the robot platform would ignore that intent and it would send it straight off to the Q&A maker. So we actually have like a level of understanding or not understanding that we mark at a finite point, and we say, okay, if you can't understand it, then go to Q&A maker. If you're confident that the intent matches something that the robot is able to do, then go ahead and action that. And we'll talk about what we do when we action that later. So Q&A maker, if you're not familiar with that, is a really, really great tool anytime that you need a place for people to ask or simple question and answer pairs. If it was something more complicated, like, hey, find me a document or find me a web page, then we'd actually use cognitive search, but that's probably a whole nother topic for a whole nother talk. Q&A maker is really about simple question and answers. So for example, frequently asked question pages, or situations like this where people might say lots of different things to the robot that only require a verbal response. So these don't require the robot to do anything. They don't require the robot to move. They don't require the robot to look at something and figure something out. They don't require much intelligence, just the ability to reply. So this is where we can have loads of stuff like loads of cool stuff like, what is your name? And what will happen is that we can find a whole load of, and these are pre-written by Microsoft. I didn't sit here and write all of these. Loads of different ways of saying what's your name, with whom am I talking, to whom am I speaking, introductions please, and then you can just add a simple answer. So in this case, we've just added Rory. Another example is we can put in, okay, that's not a good example. Let me just look through here. Something like, okay, a question like, what if I want to attach my own hardware to Stretch? So someone might be asking in-depth questions about the specific robot platform. These were actually taken from the Stretch RE1's frequently asked questions pages. So these were automatically applied from Stretch's own pages. So you can just give it the URL and it will go away and scrape that and give you all of the answers that you need, which is really cool. And then what happens is that when we click test in this case, we can then ask like, hey, what's your name? And then, you know, it's going to say hi. So let's try that again. What is your name? Rory. Okay, where are you from? I'm in the same room as you. Okay, that's true. He's behind me, right? So even though this is a cloud-based service, we can specialize it and we can train it to give any answer or result at you that you want. Let's try who made you. Okay, people created me, but not the way people created you. So that's a kind of more interesting response. This is from Microsoft's bot personalities. So Microsoft provide a few different personalities. This one is the witty personality. There's also like a professional personality, a friendly personality, and like a children-safe personality, I think, that will answer any questions that children have. And this is a really great and very quick way to add like a bit of personality or a bit of flair to your chatbot assistant, because it's going to be able to answer in ways that you know, reflect the setting or the application, and it's going to be able to answer a lot more questions. So if you just started with a blank knowledge base, it's not going to be able to answer any questions. But if you start with a personality as a knowledge base, it can already answer loads of different questions. What it can't do is something that needs actioning. So if we ask this time, what is the time? we get a kind of nonsensical answer of, okay, let's mime. Okay, those two words rhyme. But the Q&A maker isn't actually able to do anything or action anything. So that's when we need to use Lewis, because the time actually needs to be read and understood and then spoken out. So I just really want to quickly show you some of the Python code for time, just because it's quite simple and easy to understand. So what we do is in these, when we get an intent, if it matches the time, we then, and let me try and make this a bit bigger, we can then actually make a function within some Python code or whatever code that you happen to be using. All of these cognitive services are really super interchangeable. And I'll give you the link to the GitHub so you can see all of this. So we have a function for the time in that case. So what we do is when we receive that intent for time, we get that time now. We format that into a speakable way. So we just have the hours and the minutes, and then we actually get the robot to speak. The time is speakable, then the speakable time. So like right now, that for me, that would be for 16:28 or 4:28. How do we actually get it to speak though? How do we actually, get a piece of hardware with a to speak? Because all of this stuff so far has been text-based. Lewis is text-based. It takes in text and gives out text. Q&A maker is text-based. It gives in text and gives out text. So how do we actually give the robot a voice then? Well, the answer, as you might have guessed, is another Microsoft Cognitive Service. I'm not sure you'll be able to hear these, but I will put the link in the chat really quickly just so you can have a go yourself. There we go. So you can actually come out and try all of the different, I don't think this will work if I play it because I haven't done the. Yeah, okay, an error occurred anyway. So let's try that again. But using that link, you can play around with any of the voices that you want.
You can add a customizable voice to your app, service, or robot.
So I'm not sure if you could hear that, but I'll give an example of it working on the robot at the end as well. But this service takes in any text at all and turns it into speech. There's loads of different voices to choose from. You can have English in lots of different accents. We can have Japanese, Korean, all sorts of different languages. I tend to use the one from the United Kingdom because I'm from the United Kingdom. And then even within those accents, you actually have access to different types of voices. Some of these you can see are marked as neural voices, and then some are marked as non-neural. The non-neural tend to be slightly more robotic, or they don't quite flow as smoothly. They sound a bit more like Stephen Hawking, or some sort of computer from a science fiction show. Whereas the neural voices sound much better. The difference is that these models have been trained with neural networks on Microsoft's systems. So these take a huge amount of voice data to turn into voices, but those have had more powerful training, and these are kind of more up to date. So these have only been available for about a year and a half, 2 years, I think. What we can also do is there is actually a possibility to make your own custom voice. So you can record yourself speaking. It does take hours and hours and hours. I will warn you in case you want to try it. You can record yourself speaking for hours on end to a transcript, and then actually upload that to Microsoft's custom voice fonts service and turn yourself into a digital voice. Unfortunately, it does take quite a lot of time, and it takes quite a lot of expertise, especially around there's very specific requirements around microphone to noise ratio. Otherwise, you get quite a lot of static in your voice. But Microsoft already have a lot that we can use out of the box. This is really great for, examples and purposes like the Stretch Robot, where we want to give a physical device a voice. But it's also really helpful if you're building a website or an app that you want to make more accessible. So anybody with difficulty seeing, anybody with difficulty reading text, on a website is going to find these sort of things really helpful. So if you are developing a text-based chatbot, you might want to think, oh, how are people with different abilities actually going to want to interact with this particular chatbot? Adding speech is a really easy way to be more inclusive and accessible without really having to do much work, because the implementation of this, you can see, is quite easy. We can just send it off to a Microsoft Speech Service. I think I'd actually do it in the other one. We can just send it off to Microsoft Speech Service. So we need some Azure details. We tell it what voice we want to use. So in this case, we use a voice called Ryan Neural, and then we just ask it to speak it out. So it's really easily implemented. Like all of the Microsoft Cognitive Services, if you just go to the main page for them, scroll down to Get Started and Documentation, you can see loads of tutorials about how to get started with that. You can see these are available. So I've used the Python ones, for example. So if you follow this, you'll get exactly the same outputs as we have. But there's loads of other ways to do this. You can do it C#, C++, Go, Java, JavaScript, so many different languages. But even if you don't want to write any code, or you don't want to, learn Python just to implement this, you can also do it by REST. So just using, endpoints, URLs, and some, a little bit of information. You can do this by REST. So that makes it really accessible to anything that you're developing on, and really easy to integrate. The benefit of using some service like Python is that they actually have libraries around the speech intents. So rather than, for example, just using Python to do a REST call, you might actually use the Python library to do the speech synthesis itself. And that means it will be happening in some cases on board the platform. So all the speech syndication actually happens on the robot. So there's a much lower delay in the time that it takes to speech than if we had to send that information off to the cloud and to get it back. The next thing I want to talk about is vision. So obviously a great thing about Stretch is it's got a really great camera on board. So how do we add some intelligence around what we'd like to see? Well, we can use Lewis, and we can use the text to speech and the speech to text to actually ask the robot, hey, what can you see? The robot will then take a picture, and then it will return some really cool results from the Microsoft's vision services. Again, if you want to test this out for yourself on your own picture, if you just go to Azure Computer Vision, on the main page, again, they have a demo of different images. So you can upload your own images, I think somewhere. I think there's somewhere you can click, give it a go, and it will upload your own, or you can look at the ones existing. It can also read text, loads of other cool stuff. So you can see it can read text. But what we're looking to do is really for the robot to try and understand its surroundings. So taking a picture in and saying, what can you see? Well, in this case, you can see, okay, there's lots of different stuff here. There's seating, there's people, there's a laptop. What else can we see? Yeah, the laptop there, footwear, it can even see. And then it will be able to actually give you those tags, so it can see a woman, front, using, talking, so it knows that they're talking specifically, and loads of cool additional information that you can try out for yourself. In terms of what we're trying to do, we want the robot essentially to describe what it can see to us. So the only way that the robot can feed back to us is either by moving or speaking. So we want it to be able to speak. So I've taken two examples because we're actually doing two different things with two different services. The one on the left, what we get back is that the robot will read out a desk with a laptop and a monitor on it. So that's great. That's pretty much what that picture is. It's got my laptop, it's got a monitor. There's a few additional pieces of information. So it knows that we're indoors, for example. It knows that there's some electronics there, and that it can differentiate between the computer and the laptop and the display, which is really interesting. Then if we look at the example on the right, whereas I just got in the way for this photo, we can see it can still see all that same information, but this time what it actually says is a boy sitting in front of a laptop. Okay, so it thinks I'm a boy, but it knows that basically there's a person in front of that laptop. We can then use that to make a decision to look at the Microsoft's Face API, to see if that's actually someone we recognize. We do that in the next part, so we can actually see, yes, there's a face there and the ID matches that as someone. So then the system will actually be able to read out that I can see Fergus specifically in front of a computer or a laptop. Same as if we have a group of people, we can recognize different people. And this is kind of where I wanted to start talking about parallelization and how to kind of make these experiences a little bit better flowing and interactive. So you can imagine what we're doing when we say, what can you see, to the point where we get, I can see Fergus in front of a computer, is we are doing speech to text to say, what can you see, into text. We're then sending that text to Lewis to get an intent out. We're then using that intent to take a photo. So the system has to take an actual photo. And then we have to upload that photo to the vision service to get the background information like laptop and computer. Then we also have to send that picture off to a facial recognition service in order to identify if there's somebody in that. So very quickly, we've gone from a simple implementation of a few cognitive services to a string of events that to extract as much information from the surroundings of the robot as possible, that we've actually got 4 or 5 different things in a row. And then at the end of all this, we have to say, and this is what I saw. This can get quite slow, especially when we're using a limited amount of processing power on the robot, and we're relying on an internet connection. We're relying on Microsoft Azure to give us the answer back quickly. Doing these 5 different things can be quite slow, but we don't have to do them in order. So in the example that I just gave, you might think, okay, if I ask the robot what can it see, it would say, I'm looking. It would then kick off the vision process, which includes taking a photo and uploading that, getting a response back. Then it uploads that photo to facial recognition, and then it gets a response back, and then it actually reads out the answer. So it says, hey, this is what I can see, and actually reads out the answer. But there's no reason that we can't do these in parallel and save a lot of time. So what we actually do on the robotic platform, and is something that you can consider for your projects as well when you have like lots of individual processes running, is to parallelize them or to do those all at once. So in our case, we actually kick off the 3 processes at once. So that's the starting of the speaking of I'm looking. The purpose of I'm looking, by the way, is just to show that the robot has understood the intent correctly and is going to start doing something, rather than just having like 5 or 6 seconds of silence where a user might think it's not doing anything or nothing's happening. We start those off all at the same time so that they can run in parallel. And these are cloud services, so they may be running in different parts of the world. We wait for the response, and then once we've got the response from all of those 3, we then say, I can see A. So in our case, the vision process or the facial recognition process might take the longest. So we wait until we've got the response from all of that, and then we can formulate our answer. And this is the sort of thing that kind of helps speed up your interactions with chatbots and makes those interactions a little bit more human or a little bit more usable. The top example, what will happen is you'll ask the robot to do something. It will then speak, which takes 3 or 4 seconds, then start doing something, which takes 10 or 20 seconds, and then start speaking again. So it seems very sort of clunky and disorganized. In the second example, we'll get the same immediate reaction of I'm looking, but by the time we finished saying I'm looking, we're actually, halfway through the vision process and the facial recognition process, so we don't have to wait very long before we can say I can see A. So this makes the robot seem more responsive, a little bit more intelligent, a little bit more useful, even though we haven't actually done anything to change the way that that's done. Specifically in Python, the way that we do that is we use a library called Asyncio, or to do asynchronous requests. If I just find the vision intent, you can see what we're actually doing here is we're starting 3 tasks all at once. So we're using Python's Asyncio to start an image task, to start a speech task, and to start a face task all at once. And then once we've actually awaited the results of that, we can then go into the logic. So in this case, we've got some logic just to say, hey, because there's different amounts of people, different things we can say before it will actually say, I can see a, whatever it is in that example. So this is a really powerful way of making your applications, no matter what it is, no matter what it's based on, a little bit more responsive and interactable. So I wanted to kind of finish off by quickly giving you a demo, hopefully, of the robot working. So I hope you can see me on the camera. I might just stop sharing just to make sure and spotlight myself if I can. Okay, so hopefully you can see this. So if I start up the robot, hopefully you can hear. It's now not going to work, is it? This is why I was apprehensive of doing a live demo. What is going on? Starting up. Okay, there we go. So the robot will say starting up in its neural voice, and then it's probably going to get very confused because I'm talking like this. I don't have the capacity for thermoregulation. Yeah, so that's thinking it's done the weather intent. Let's try this again. Don't know why it's being so slow now. So I'm going to try it again. It's going to say starting up, and then I'm going to ask it what the time is. Then I'll ask it to say what it can see, and then we'll see how responsive that is. I am having a problem with this particular robot at the moment, where the longer I leave it on, the slower it gets. So it's been on this whole time, so it might just be a little bit slow. Starting up. What time is it? The time is 16:45. What can you see? Yeah, never do a live demo. I'm looking now. Oh, there we go. Yes. I can see a desk with a laptop and a monitor on it. Okay, so we get the answer. Usually it's very responsive. I don't know exactly what the issue is. I will try restarting it maybe. But we can also give it commands to move up and down. So you can see here, we've got the lift, the wrist accessories. We can use it. We can use the voice commands to move it as well. As I said, if I restart it, it might be quite quick. So I might just do that whilst we're asking any questions. But otherwise, I will kind of wrap up there and say, thanks very much for listening and for your attention. And if you have any questions, please let me know. I'm also going to put our GitHub repository in for the specific stretch, just so you can have a look at any of the code if you want to look in more detail. And you can sort of visit that, explore that. Could I try the mind control? We'll see how quickly I can restart it, but I can quickly talk you through the components with the mind control. I might be able to give you a demo, like a different type of demo, not necessarily connected to the robot, just because I'm not sure how long that would take to set up, if you'd be interested.
Yes, sure, yeah.
Cool. Okay. There goes the robot. I just want to quickly try something. Starting up. What can you see? I'm looking now. I can see a desk with a laptop and a monitor. Okay. So for whatever reason, that was much quicker. I don't know what happened to the robot, but that's like an example of it's doing all those streams of different things at once. So, you know, we can get really quick when it's working properly. We can get really quick responses from the robot. I can try a move command as well. Let me just try this. Starting up. Move your arm up. So that's just an example of how we can actually use the voice commands to move the robot. You know, that could also be really helpful for somebody looking at assistive technology or anything like that, or just like controlling the robot in general. We can also control it through this Xbox controller as well, which is super helpful. For the next mind stuff, I will just share my screen really quickly again. Window 8. Yeah. The problem with the next mind and doing it like quickly is that the device requires calibration. So I would have to calibrate it on the robot, which would take me a while. So I will just have to trust that you believe me when I say that the stuff that you'll see on here will work. But it would be difficult for me to calibrate those things together. Okay. So all I do is put it on the back of my head to make contact with my scalp. And then, of course, it's not going to even find it. Let's see. If not, I can show you a video of me using it because I don't exactly know what's going on. Let me just, I will leave that to see if it will find this. No, I think for whatever reason, I have to connect it as a new device. There we go. Okay, let's see if we can do this really quickly. Okay. Let's see if we can do this. So I just have to put it on the back of my head and wait for a good connection. So it says we've got a good connection. Great. So now what I have to do is calibrate the device. So it's going to ask me to focus on that. So you can see I'm not doing anything with my hands, but I think this is going to give me a very good score. And this process takes about 45 seconds, so sorry if it's being slow. So you can see when the triangle is closed and small, that means I'm focusing. And then when it's wider, that's not quite getting my focus. I think the calibration score is going to be quite low on this, unfortunately. Give it a go. Yeah, I've got a pretty poor score. But now the idea is that I would be able to focus on these 3 circles. No, that's not working. Okay, so the idea is that if you are focused, you should get. Just find the video actually. When you get a good enough calibration score that it is able to use your focus on to figure out what exactly you're looking at on the screen. So this is an example of when it is calibrated. So and it's slightly sped up. You can see my, I'm not doing anything with my hands. I'm not touching the keyboard. I'm just using my focus to actually align what I'm looking at along the bottom of the screen to play a game of block, which is super cool. There's also a pin pad number 1. I just can't remember where it is because it wasn't prepared. Yeah, I can't remember where it is. Maybe in the general channel. Give me 1 second. Put your. That's a Pringles that I break. Okay, let me just see if it's on my phone really quickly. I can't find it there.
So why is trying to set that up? If you have any questions.
Yeah, please feel free to type any extra questions. Let's give the calibration. We've got a few minutes, so let's try the calibration one more time. But if you have any questions in the meantime, just feel free to pop them in the chat, and I will answer them as soon as done this. I might just stop sharing my screen quickly whilst we do this, and then I'll share it again when it's connected. So just bear with me. Okay, I think that one was a bit better. So doesn't like to be shared through Teams, apparently. Yeah, I feel like we're learning a lot. It doesn't like to be shared through Teams. Okay, such is life. Okay, let me just try and find this. Yeah, if you have any other questions about any of the cognitive services, any of the work that we've been doing, otherwise I will I put a link to the Azure Microsoft Cognitive Services. I will put a link to our GitHub. So if you did want to look at any of the code or any of the stuff that we've been looking at, you can feel free to look at that. And I'll also link to NextMind in case you want to like learn more about that particular device. They got some really cool demos and videos as well. And then I will try to find the video really quickly before we have to head off of me using the NextMind successfully. Let me try to search Teams.
Like we're running out of time.
Yeah.
So if you have any question, signify or just speak up.
I will try and find a video and then hopefully like goodness if I can like link that to the community in some way, but yeah, sorry. Sorry, couldn't get that to work. But yeah, thanks so much for having me. It's been great to talk to you and hope you found something useful in there.
Oh yes, thank you very much, Fergus. Thank you for making yourself available. Okay, so let me just make this known to the community. Fergus was actually not supposed to be our speaker for today, so he's standing in for Chris, who couldn't make it, unfortunately. So it was really at the dying minute that Fergus had to jump in to stand in for Chris. So we really appreciate your commitment and your efforts for agreeing to up on the call this evening. Thank you very much, Fergus. And we hope that soon again.
Yeah, well, thanks so much for having me. I've just put a link to my LinkedIn, so feel free to like add me on that if you have any additional questions or like want to keep up to date with what we're doing. Hopefully some of the work that with NextMind and the robot will be being published by NextMind on their website, so you know, lots to explore. So you know, happy to connect with all of you, and thanks very much for having me.
Yeah, thank you so much, Fergus. I think we lost goodness.
Yeah,
it's wonderful having you. The mind control stuff was very, very interesting. I'll be sure to check that out, and I'm sure everybody here will be very, very interested in that. So thank you so much for joining us. We
no worries.
appreciate.
Maybe we can go over it in a bit more detail in another session, or I can invite someone from NextMind or something to give you a separate session on it, because it's such cool technology and has like some really great use cases. So excited to see.
Yeah, that would be great. We'll talk to goodness. He should be able to set that up. If we are very happy.
Awesome. Well, thanks very much. Enjoy the rest of your Saturdays. You know, thanks for taking time out of your weekends to join us, and I will see you again sometime, I'm sure.